Okay. All right. Good evening, everyone. And this is Paul AA0RS. And we're going to see a great presentation this evening from my good friend Dave AA0RS from Platteville, Colorado. And he shows us how he built his own 6-meter EME array from all by himself with his bare hands. And this is it's amazing what you can do when you got your mind to it. This is the first slide of the presentation, and Dave, can you see it okay?
I don't see the slide, but
okay, let me go back to that again. Okay, how's that?
no, I can see the words.
Okay, that's the one you want.
Okay, mate. Well, that's okay then.
All right, and you can carry on from now, okay?
Well, I'm going to have to pull up the PowerPoint presentation somehow. And
I've got it. I've got it going here, so you just get yours up, and then I'll just tell me when you want another slide to say next.
All right. So, right. Hang on a second. I've got to close this slot down so I can pull it up. How do you minimize this screen, Paul? Do you know?
No idea.
View options. Hang on. Here we go. Exit full screen. Oh. There we go. Okay. Now I can get it down. PowerPoint. There we go. Okay. So yeah, the first picture gives you an idea of what it is we're going to be talking about. The first thing I did after I did the paper design of this thing, I should emphasize that cross-polarized yagis on 6 are pretty big. And even when the antenna is in the horizontal position, the bottom of the vertical elements on the bottom yagis are about 10 feet off the ground. So as you rotate the antenna upwards, those elements get pretty close to the ground. The optimum spacing that I could gather from various sources for a 4-element array of this size is about 24 feet, something in that region. Going more than that, the beam apparently starts to split. And if you don't get it far enough apart, you don't have it sort of fattens the beam out a bit. So the first thing I did once I got the paper drawings done as to how high I had to make this thing and everything else was I started contacting companies that hired out man lifts and things like that. They don't like hiring out anything that will go up to 25 feet unless you've got a heavy goods license. And they really don't like private individuals driving on what they consider rough ground with a 25-foot man lift. So, and they weren't available anyway.
Dave, do you want me to go to the next slide?
No, it's okay. You can stick on this one just for a second.
Okay.
So the problem I had was that I couldn't easily get a man lift, and they only rent them out on a monthly basis, and it's about $1,000 a month. So you can imagine it doesn't take long to start throwing a lot of money away. So what I did was to modify this forklift attachment that I had on my tractor. I put a piece of Roan 25 up on the backside, made a hinge bracket that clamped onto the forks, and then fitted winches and that on it. And this allowed me to make basically a small crane. Very rarely did I operate the crane with the forks off the ground. And that kept everything very stable. So it worked out pretty well. So the next slide, please, Paul, number 3. Have we got that up? Paul, are you hearing me?
Yeah, can you see the antennas?
Well, no, well, I don't see the slide that you've got. I put it onto slide number 3, which just shows. It just shows the tower with the tripods connected.
Okay, I'm on the second slide, so I'll move to the next slide.
Yeah.
It says getting started is the title.
No, the title of this one is Roam 25 was used to support the array.
Okay, well, I wasn't on your right slide when you were talking. That's why I was trying to make you move there. Okay, I've got a picture of the tractor right now.
Okay, well, that tractor, that's the bottom of the crane attachment that I was talking about. And you can see the winches and that on that. It just gives you an idea of if you decide to put one of these things up, it's a way of making a crane so that you don't have to keep hiring man lifts and things like that. So
Okay, now I'm on your Roam 25 now.
Right. So when I first put this thing up, the first rotator that I bought was one of those Polish Procell things. And this is what it looked like. This is what the tower configuration was at that time. It became pretty obvious once I started building it that the Procell rotator wasn't going to do the job. So I had to abandon that, and the whole top section that you see here wasn't man enough for the job. So I took that down. And I started off on slide number 4. I bought I already had 3 or 4 sections of oil pipe. This is like 2.5-inch diameter pipe. And I welded feet on the bottom of the 3 pipes that were going to form the tripod around the Roam 25 tower. And if we go to you can see the angle where I've welded onto the base of the pipe in that drawing. And if we go to the next one, this is number 5, Paul. It shows the top of the pipe, and these are the brackets I fabricated to attach the pipes to the tower legs.
Okay, I want to make sure I'm on the same number as you are, because I'm not necessarily seeing the same things. This slide is titled 3 sections of Roam 25 at the top. That's slide 5.
Paul, you need to add 2 to the number he tells you, then I think you'll be in sync.
Okay, thank you. I'm glad somebody knows. All right, so what slide do you want to be on now? This is the one here, okay, showing the brackets at the bottom.
Right, okay.
Okay, that's number 7, that's fine.
Okay, so that's number 6 or 7. That's number 7, right? Okay, so if you look at number 7, that L shape that you can see there, you can see the 2 holes at the bottom of it. There's 2 more holes below that, and that's where the U-bolts go through to the tower leg to hold it on. And that means that this leg is flexible. So if we go on to number 6 then, Paul.
Yep.
Okay, so I used just a sanding machine to clean the pipes up, and then I spray them with grey paint. On the pipe on the right-hand side, you can see the size of the foot that I welded on the bottom of these things. Okay, so if we go up to slide number 7. So I dug a hole, filled it with concrete, and climbed up the tower and clamped the leg, this steel pipe, onto the side of the Roam tower. And when I got all 3 in there and tamped the concrete down, just left it to go hard. And the tower is now, you can swing around on the top of it and it doesn't move at all. So number 8 shows it from a bit of a distance. You can see I had an old piece of Roam 45, which I slid down over the top just because it was handy. I didn't really need it, but so you can sort of see that at the bottom of the picture. So then slide number 9 shows the revised top section. The Polish rotator that I mentioned was a complete unit in the respect it did azimuth and elevation. And I wasn't going to go through that mistake again. So I fitted the M squared rotator at the bottom of this tower section, big rigid pipe with 2 bearings, and then hoisted that in the air. And you can see that on slide number 10. You can just see that the tractor's in position. I've got the short jib on the tractor at the moment. It's nearly double that for raising the antennas. There's another piece that goes in the top. So you can see the that's the way I got that thing up in the air. So if we go over to slide number 11, this is the boom of the antenna. It's another section of that 4.5 inch, 1/4 inch wall aluminum with some extension pieces fitted to give me the 24 feet separation between the antennas. Very heavy. And you can see in the middle of it, I put 2 brackets and attached chains to the tractor to move that thing into place. So we go on to number 12. Unfortunately, I didn't take a lot of pictures because I hadn't envisaged doing a presentation of this. I didn't think there'd be enough interest, but you can see now, you can see the boom in position sitting on those blue boxes. All of the diagonal struts are fiberglass. There's nothing in the main field of the antenna apart from the H beam running across the thing. That's the only piece of metal that's above the boom. Everything else is either very short pieces of aluminum or fiberglass. The 2 bottom antennas don't need a boom support, a separate boom support, because the bottom of the H frame is where I attach the ropes that hold the antenna from drooping. But the top antennas needed an extension, and that's what these square pieces are, so that when the antenna's in place, the tensioning wires to keep the boom from sagging go through these, go up to the top of these 2 pieces of thick fiberglass. Does that make sense? Does everybody following me there? Okay, don't know.
Yeah, if anybody's got a question, just unmute.
Right. This is the main boom to vertical section brackets. The main piece on the bottom there is steel. That's 1/4 inch steel plate, and then the rest of it's just aluminum, thick 1/4 inch thick aluminum plates.
Are you into the next slide already?
Yes, that's slide 13.
There we go. Got it.
So the piece of aluminum at the bottom of this, underneath the big steel plate, that's the boom. The horizontal piece is the leg going up and down, and then the piece going up is the piece that holds the 2 diagonal braces on each side. This is copied on the other side of the H frame. So if we get into the next slide, Paul, this is slide 14. I just used whatever scrap aluminum I had. You can see this has been used before on other things, but all of the main brackets are 1/4 inch thick at least. And I bought, I found a source of supply of the pipe fittings, the U-bolts with proper saddles and everything. And some of them turned out to be really quite inexpensive. So if we pass on to the next slide, you'll see here, this is the sort of triangular plate on the top of, or the top and bottom of each of the H legs. And this is where the antennas clamp onto, this black piece. And the antennas sort of sit on top of this fiberglass tube. These fiberglass tubes are actually two tubes slid inside each other, and then a short aluminum piece is fitted inside that, so that when I crank on the nuts to tighten up these U-bolts, they're really tight. And the piece going off to the left there is the diagonal support to stop the antenna moving around too much. So if we go to the next slide, I'll take you back to the extensions for the two top antennas. Because my height limit on the scaffolding that I had was about 22 feet, and it wobbles around like crazy on rough ground. I didn't want to have to reach up to 4 feet to try to get to the top of the and you know, adjust the turnbuckles to tension the wires. So what I did in advance, I fitted two pulleys, one on each side of that, and I brought the tensioning wires down to the boom and fitted the turnbuckles there. So I was able to get to them without sort of risking life and limb. And that turned out to work out pretty well. You can also see on this slide that instead of taping the coax like it is on the boom, you see all the tie wraps. I actually spiraled it around there because it's very difficult to get in, you know, hang on the side and try and reach out and get tie wraps up in these places. And I also found that these tie wraps, which were about 3/8 of an inch wide, and I bought what I thought were the best that you could get, UV rated, you know, all sorts of claims made. Well, these things didn't like cold weather, and a few of them popped off even before the winter really got going. So I'm still not impressed with them, but there you go, they're already up there. So if we get down to slide number 18, please, Paul. You should be seeing, this is a picture of the tractor holding the H-frame up against the tower. Is that right? You got that?
Roger that.
Good. Okay, so this frame, I don't know what it did weigh because I didn't actually try and weigh it, but it's got to be close to 200, 250 pounds, I'm guessing. Nothing for the tractor, but I didn't want to try dragging this thing up so that it was scraping all the way up the tower. So I balanced it on two sections of scaffolding, and I'd already installed a pipe, a very heavy, strong steel pipe into the top of the tower with a rope coming down attached to the boom. So as I lifted up with the tractor, I got out of the tractor, went and tightened the rope up at the bottom, and until the thing was up at about this angle. At which time I went to slide number 19. Have you got that one, Paul?
Roger that.
Okay. Now that I've added the extension to the crane jib, I've also put a backstay over the back of the tractor just to make sure that when I lifted this thing, it didn't go anywhere. And what I did, I just cranked on the winch and slowly pulled this thing up, pulled it up maybe 2 or 3 feet at a time, went back round and tied the rope up, you know, kept tensioning the rope on the pole sticking out the top, so that at any time if something slipped, it wouldn't actually come down vertically anywhere. So if we got to the next slide, which is number 20. And this is where the frame is now almost dead vertical, because as soon as you get it vertical, it swings into the tower, and that amount of weight would certainly shake the tower around a bit. So I was very careful to just allow it to sort of slither its way across the surface of the soil where it touches the soil until it was in place. And then it was a fairly simple job of just keep on winching it up slowly but steadily until the horizontal boom frame there of the frame lined up with that M² rotator that you can see at the top of the tower. And when it was all in place, slide 21, and all the garbage was moved out of the way, you can see, probably make a bit more sense of what I've been saying about the metal pipe is gone out of the top. The H-frame is now bolted onto into the rotator unit, and all the garbage is gone from around the bottom. And then the next slide, 22, Paul, shows a side view of what the thing looked like when it was in full position. The antennas, once fitted in this position, would be about 0.1 degree above horizontal. So now that that was all finished, it was time to start on the antennas. So if we go to slide 24, like I said, each element's 10 feet, more or less 10 feet long, and there's 5 feet sticking in front of you at any one time. So I made up some tripods, and you can see them in this picture, Paul. Is that what you've got in front of you?
I think that's Roger.
Big green tree. You can see the tractor off to the side, the left side. Yeah.
I can see the tree or no.
Yeah.
I wonder. Okay, I'm just looking at the antennas now on the tripods. Got it.
Yeah.
This is slide 24 for you. 26
Yes.
for me. Got it.
Yeah. So this is how I fitted the elements on, and even though these tripods were made out of scrap, they didn't quite give me enough clearance. So I bolted this about halfway down the boom of the antenna. You can see another fiberglass pole there, and it's clamped onto the boom. And the top of this pole is where I attached the temporary supports to stop the boom flapping when I moved it around. And if we go to the next slide, Paul, 25, that makes it a little bit clearer as to what this thing was for, because constantly any slight breath of wind or anything like that would cause these elements to start turning one way or the other. You know, the whole antenna wanted to keep on wandering, but as soon as I fitted this leg, it stabilized everything, and it also gave me 2 points to attach the ropes to, the tension ropes. And the next slide shows that a little bit clearer. 26, Paul.
Yeah, right on it.
Okay, so once the antenna was built up like this with just the horizontal elements in place, then I picked it up with the tractor and I moved it round to the field close to where the tower was, and put it on another set of tripods that I'd made, and then I fitted the vertical elements. And once they were all fitted and as just adjusted to what they're supposed to be, I coiled up the coax and started picking the antenna up, only to find that because it wasn't, because I was picking up at one point and it wasn't balanced, it was a nightmare to control it. It's 30 feet long, it weighs quite a bit, and I ended up putting it back down again. And if we go to frame number 28, Paul, I made this thing. I made this this bracket with a couple of turnbuckles on it, and that allowed me to, the antenna didn't wobble around anymore. It stabilized it quite a lot. And Martin in the Curacoa there, this is well worth making, I would suggest, just for moving the antennas around. It worked out really quite well. To give you a perspective of this, if we go to the next slide, you can see the size of the antenna and all the elements on it. And this is actually how I moved them around the field and got them in place to put them on the tower one at a time. The next slide, Paul, number 30, shows what the boom sags like if you try picking it up without that bracket thing that I made. This is what it sort of looks like. So it's definitely something on a long boom like this. It's definitely something to think about how you're going to get around this problem of the thing sagging when you move it. Okay, the next slide is number 31, and this shows all 4 antennas built up and in position to be lifted onto the tower when conditions were right. I didn't want to try doing it on a day when there was any wind or there was a threat of rain or anything. These are just 5-foot horse panels, and again, if you're going to be doing a 4-bay array, Martin, it's you've got to find somewhere to stack these things because those elements poke out all over the place. The next slide shows what I call a squatter that moved in right in the middle of the crane there. Can you see that?
Yep.
See a little birdie? She hung around for a few weeks, but eventually she got fed up with all the movement and that going around. I left the crane in place for her, but and eventually I tried moving the nest, but she wouldn't come back to it. So, but that was an interesting. So if we go to 33, this shows the next problem, which is picking those antennas up off the horse panels. And in order to do that, I had to lift the fork off the ground and lay the boom over horizontally, almost on top of the antenna. And then the hoisting rope got attached more or less to the midpoint of the antenna. But as you lift it up, so the antenna wants to swing in towards the tractor. So you can just see an 8-foot pipe that I put at sort of face height. And before I started lifting, I attached that to the bottom of the antenna, which would eventually be the front of the antenna, with about a 6-inch piece of rope so that it could move slightly. Then as I hoisted this thing up into the vertical position with the jib was horizontal, I attached the rope to the middle, the hoisting rope, attached the rope to this 8-foot pipe onto the bottom of the antenna, and then I cranked the boom up so that it went up vertically, and that was the way I was able then to move the antenna, the 2 top antennas into position. So if we go to the next slide. Because there's 2 big coils of coax on each antenna and a fairly hefty ferrite ballon on each, both the vertical element feed line and the horizontal, the total weight of that coax and the ballons was just incredible. I mean, it was almost difficult to lift. I bought some colored heat shrink, the red heat shrink here, and I put that on the one end, the feed point on end of the coax, and I put it on the other end that would be connected to the combiners so that I didn't get confused as to which were the vertical elements on the various antennas. I paid particular attention to the polarity to make sure that all four, when they're hoisted in the air, the polarity of the coax feeding the loops was the same.
What's that white stuff on there, Dave?
White stuff is a rubbery paint that you can buy. It's electrically insulating and that, and it just keeps the moisture off everything. So if we go to slide number 35, this shows the first of the top antennas in position, and you can now see those boom struts coming down the side of the fiberglass piece at the top there, and you can see the coiled coax coming down. Then if we go to the next slide, which looks pretty horrific, slide number 36, this is actually the last antenna going into place. I didn't, as I say, I never intended to do any sort of presentation on this. I didn't think anybody would be interested. So I didn't take as many photographs as I could have. But every time you've got to climb up and down the scaffolding or in and out of the tractor and you're worried about the wind getting up and that, you end up throwing the camera to one side after a while. But you can see how useful having this crane device was. I mean, I couldn't have done it without doing that, without building that. If we go to the next slide, you can see the combiners, two lots. The purple tape shows the vertical, the one for the each side's got two vertical antennas connected to it, and the horizontal ones go on the unmarked ones, and they clamp onto the boom, and that allowed me to reach out from the steps of the tower, from the rungs of the tower. It was fairly comfortable to reach these end connectors on the end to attach all the antenna coax lines.
How did you seal the end connectors on the ends there? What did you do to keep them?
Yeah, I used self-amalgamating tape. You know, that black stuff that you wrap around and stretches.
Yep.
And then once that was in place, I then coated that with some plastic tape. You know, the good stretchy stuff you can get from Home Depot. It's about $3 a roll. That's really good stuff for doing that. So the next slide shows the final combiners, where you take each pair, the two vertical pairs and the two horizontal pairs, and they go into these two combiners. And that's also connected up there onto the boom. So that more or less covers everything I have in terms of actually building the array. The sad part was when I built the first antenna, when it was on, you know, when the horizontal section was on the ground, and I was about to move it, I just threw the VNA on there to have a look and see what it looked like, and it was terrible. It didn't look like an antenna at all. And it turned out, when I started finding out what had gone wrong, you've got the coax picture there of you, Paul?
Yep.
Yeah. What it turned out was that the inner core of this coax had shorted out. It had pushed forward. When these coaxes were made back in the UK, they coiled them up into about an 18-inch diameter. And the inner core, because it came out of the end, basically. I had some of the end connectors where the pin had either gone into the connector almost completely, or it had pushed out. This happened to be one of the ends that connected to the actual antenna. It wasn't the only one either. If we go to the next one, Paul. There I've got the ohm meter on the end of this piece of coax. And you can see it's the ends where it's resting on the vise there, they're open. but we got 254 ohms on this piece of coax because of that shorting effect at the end. So I abandoned that coax. I bought some LMR 400 UF, which is much more flexible than this stuff. This really isn't suitable, I would suggest, for an array where you've got lots of moving parts and you've got 4 or 5 coaxes all being bent at any one time. The other thing about this is, while I was making the new coax cables up, I evaluated this ferrite balun, and in my experience, if you can get 500 ohms impedance along the sheath, that's adequate for something like 6 meters, especially. And I reduced the size and the weight of this thing by half, and still had 500 ohms impedance at 6 meters frequencies. The next slide, Paul, number 41, shows after I had that experience with the coaxes, I decided I'd check the combiners, make sure that they not only did the impedance match that we needed, 25 ohms at one end, and quarter wave later it turns into 50 ohms, but when I opened them up, I sort of found all sorts of things, and this one was probably the worst. This piece of copper tubing should be in the middle of the square in order to give you the correct impedance, and it wasn't. And also these holes were pretty rough. They hadn't been cleaned off at all. Because nearly all of the combiners had this type of problem. If you go to the next slide, Paul, I got some scraps of RG390, whatever, the brown stuff, the 50 ohm brown stuff, which has got a Teflon inside. I sliced up some 4 or 5 inch pieces of that. And by cutting a piece off like that, you could fold it nice and easily. And it went down the side. 43, Paul, please. Slide 43 shows you the 2 pieces in there. And that copper pipe's not going anywhere now. So that's a modification well worth doing. I'll show you the last of what I consider the horror stories is slide number 44, where we've got these big APC7 connectors to bring in the 1.5 kilowatts. And you can see what I found in there. I mean, this piece of copper tubing has got this piece of aluminum swarf. I don't know what you call it here. That's what we call it in England, swarf. Just waiting and ready to short out. It probably was already. I didn't measure it at the time. Then if we go on to number 45, Paul, this shows the best piece of engineering equipment I've ever bought. I don't buy much stuff unless it's got a particular feature that I like. I prefer making it so I can break it without feeling bad. But this thing is really, really good. It did exactly what they said it would do. And it was very heavy. I had to use the crane to lift this to the top. But you can see the small piece of 4.5 inch boom material that I had in relation to the size of this thing. It's a hefty piece of gear. So we go on to slide 46, which shows the antenna in its, up at about 85 degrees. It's very close to being completely vertical. There's still plenty of clearance, ground clearance there for the vertical 5-foot elements. And then the last slide shows it in the nested position, ready for moonrise. That's it, gentlemen.
Very good. I think it's awesome. And where do you tie the ropes?
The ropes I tie onto those black pieces there at the bottom. I just thread the rope through there and pull them out to ground anchors, which I screwed in the ground. And when I'm not using the antenna, I always point it at 117 degrees of north. pointed basically at Florida, Georgia, because in the mornings at 5, 6 o'clock, when I get on and check the band, those guys are working each other. And now and again, occasionally, by calling and calling, eventually someone says, "What was that?" And they can hear. Sometimes they can hear the call sign. But I don't bother using this antenna for that. The other antenna I got for 6 is 2 M² antennas, the 27VH or something, whatever they're called. They're about the same size as these, and they're on a taller tower further off to the west of the house. And that's what I use 90% of the time on 6. Those two phased antennas, one above the other, just vertical, horizontals. The winds that we've had here over the last year at times have tested this thing fully. If it was going to fall down or become unstable or that, it would have done. But it's turned out to be a pretty good platform. I'm not worried by the fact that some of the weight is at the back, because once I've got this thing as good as I can make it, on the front side, I'm then going to put a multi-element 1296 432 array just on the front side of the antenna. They'll be base mounted. But I want to get all the measurements made on this, so that anything I put in the middle of it, I can see what electrically I can see what the difference is, if there is a difference. There we go.
That's awesome, Dave. And it's quite an engineering feat just to get this monster into the sky. And all the engineering or all the obstacles you had to overcome, like the coax is, the solid center conductor is like, okay, I mean, you wouldn't see these things, you wouldn't know about these things until you try to put them up. And then once you get this thing in the sky, you don't want to have to go up and change your coax.
That's exactly it, Paul. That's exactly right. And that's what my advice is: double check everything before you put it up in the air.
Yeah, so there's a lot of things that we've learned from you and this thing, and I think Martin has probably picked up a few tips if he hasn't already figured this out. Any questions? This is it's great. Let's open it up for questions right now. Anybody, just unmute yourself and you can ask away.
Does it really make sense to have both horizontal and vertical on 6?
Well, I didn't know. That's why I did it.
Because I'm planning on only horizontal.
Well, I got echoes off the moon once with this array, and unfortunately, I mean, they were very weak and they were very short-lived. Half of my call sign came through clearly. Then when I sent the call again, it had gone right down into the noise, but you could just hear the sequence. And then the third time it had gone. And I haven't been able to repeat that since, mainly because I haven't tried that hard, because I want to get, I've put up a receiving dipole right at the end of the field. It doesn't show up in this photograph, I don't think. But when, if I hadn't damaged my foot, I would be getting up there in the next few weeks and testing each antenna for phase and gain in place before sort of sealing it up again for the winter. So that's a job I've got planned for this summer.
Dave, you switch horizontal to vertical, or have you ever given any thought to a circular polarity for EME?
That's certainly on my plans. I switch it at the moment because I was cavalier enough to think that at least 1 out of 5 attempts I'd get some sort of signal back from the moon. That didn't work out, and I would be able to evaluate how much rotation there was, between horizontal and vertical. But certainly my aim is to get rid of half the coaxes and just have them all connected together up there at the top with one big circular array.
I have a couple of comments and a couple of questions. Dave, first of all, I guess you did answer the question that you right now you can feed the vertical separately and the horizontal separately. Is that right?
That's correct, yes.
Okay. My comment to Martin would be all but 3 people in the world right now have horizontal only on 6 meters. And the reason for that is
Because it's
mechanically
huge.
to do it properly. It's a mechanical and electrical nightmare to do cross polarization on 6 meters. And to really do it right, you need to have the coax come off the back end of each yagi, or the coax shield itself will be interfering with the elements in the vertical of the vertical elements. So it's a lot simpler to keep everything with just horizontal elements, and then you can easily dress the coax along the booms and the masts, and you don't need all the fiberglass and stuff, and the coax won't get in the way. What in answer to your question, Dave, I have seen a lot of fast QSB on 6 meter EME, and I've seen it during periods of low KP index where it can go for like an hour with the Faraday rotation. So sometimes, I have pictures of traces off of EME that look like somebody sending slow dashes on CW. That's how fast it can spin. But on the other hand, it might get stuck in one position for an hour. And what most of us do is we just operate in one polarity because it's simpler, and also because compared to running circular or something like that, you don't have 3 dB to lose. So eventually, over the course of time, if you're patient, the Faraday rotation will roll around right for you at some point. And so that's the way that most of us have played the game. Now, like I said, there are 3 stations, not including yours, who have cross polarized antennas on 6 meters. And in the case of HB9Q, he does always transmit in circular polarity. So his signals are always a little weaker to receive for everybody else, but then he switches his receiver between vertical and horizontal, so basically he's always there. Of course, if you get a geomagnetic disturbance or some big thing that's going to screw up propagation and scatter the signals off route from going to the moon and back, that's a problem. But the normal polarization rotation never phases him at all. And OH2BC has 8 of those yagis that you have. And he also, can switch back and forth on receiver or transmit. So they're there all the time. And F6BKV has 4 yagis that are cross polarized. And if you look at his QRZ page, you can see how he phased everything so that the phasing lines come out the back of the antennas, which is quite a bit more complicated mechanically, excuse me, but he's had excellent success with that too. So I just wanted to mention that. And so you may want to watch for that when you're making your measurements, because I suspect that the coax phasing lines are going to interfere with your vertical polarization, and you may wind up ahead of the game just using the horizontal elements that aren't affected by the way the coax is run. And one other note is that the vertically polarized antennas are, I know you weren't planning to use this for terrestrial work, but you sure could with that horizon that you've got there. It's to die for. And the problem with a 4-bay array, and especially with cross polarization, is that the vertical antennas are going to have a higher ground gain lobe than the horizontally polarized ones. So you really won't have circular polarization, even if you tried to combine them for circular polarization. It's going to be kind of screwed up until you start pointing up in the air. But I'm sure horizontally, I'm sure you'll have great ground gain on your moonrise with that array. And I will be very anxious to run some tests with you, and very anxious to see how you make out this summer on eScape with that array, because don't discount it.
Well, I hope not. And thanks for all that information, Lance. I'm new to the band in the respect that I haven't ever really operated VHF, but I thought I'll put up an antenna and try and figure it all out. Hopefully, when I start making the measurements between the horizontal and vertical, if there is some loss of performance because of the coax, I can still maybe achieve some, like you say, some sort of mixed circular mishmash or something. But we'll see what it turns out like. As I say, I've only heard echoes come back once, but since then I keyed the transmitter much faster so that I can get my old call sign in next time.
What kind of feed line have you got, Dave?
Down to the ground, it's up to the end of the combiners, it's LMR 400, and then I've got 1-inch LDF 550 or something running into the shack. The total run is about 220 feet.
Okay, did you measure what the loss was to the top of the tower?
Not yet, no. But it shouldn't be much more than about 3 dB, I don't think.
That's huge on EME.
Yeah, it's huge. Almost everybody that's on 6-meter EME now keeps their feed line loss below 1 dB so that they can have a preamp in the shack. If you have more loss than that, you probably need a preamp at the antenna, which is a huge nightmare in itself. So that's why most everybody tries to minimize their feed line loss and keep it under 1 dB, and that way they can put a preamp in the shack. And almost every rig for 6 meters that you can get at needs an external preamp ahead of it for EME, because commercial 6-meter rigs are very, very proud of the fact that they have low IMD and low distortion, and they can handle huge signals like you get on eSkip and F2. And in order to do that, their sensitivity is way, way down. So for EME, I still have an IC706, and the meter reads as 0. And so it looks like I have a very low noise level here, even when I'm pointed on the horizon where I do have noise. So I need a 25 dB external preamp on my IC706 to just get S1 on the meter. So I would urge you to think about that too. But probably the reason you haven't heard such great echo so far is the feed line loss, because the echoes are going to be weak on 6 meters anyway, and they're very rare to hear them. But that's why we use the digital mode of Q65-60A now. And with that, I mean, you've got an extra 10 to 15 dB of sensitivity over your ears. So that's the way that everybody is on right now. And if you want to send me your email address, I'll make sure you're on the Magic Band email group, and you can set up skeds and stuff that way through that group. But if you have any questions or want to compare notes with people, that's a wonderful tool to be able to just send out an email, and anybody doing 6 meter EME all around the world is on that group.
Excellent. Well, thank you. Thanks for all that info. That's good. I'll take some of that. I haven't measured the coax. I mean, it was the best coax I could find. It's big stuff. And it's about 150 feet, I guess, of that run of that big stuff. And then it goes up with the LM400. So I'll have to look into that and see what's going on. Excellent.
Well, either one way or the other, in September when I'm in FH, I'm expected to work you on your moonrise. So whether it's on your 2 Yagis that have, I'm sure, excellent ground gain aimed on your moonrise, or this array, please watch for me.
Oh, I will, for sure. Thank you.
Any other questions on the subject today? No.
How stable is this in high winds?
Oh, it's been through, Paul, what's been the highest winds recorded up our way? Do you know, 60 mile an hour?
Yeah, we've been getting 60 mile an hour to 80 mile an hour gusts at times, and you guys up there in Platteville, I'm in the city, so I get blocked a lot by the mountains here. But you're far enough away from the mountains, you don't get any relief from the wind, and you get some pretty strong gusts. I'd say 60 to 80 mile an hour gusts.
It hasn't moved any more than you would expect it to, and most of it's just due to the element side to side movement, Martin, rather than, it isn't sort of wobbling like that. It's just you've got some side movement of the individual antennas.
Okay.
I've got some information. I just ran the coax loss calculator for Andrew Heliax LDF 550. 150 feet is only 0.4 dB loss. That's not too bad.
Good. That means all the money I paid for it wasn't wasted.
Oh, that's good stuff, and it used to be readily available, but it's getting hard to find. I'm looking for a 200-foot piece myself now, and haven't been able to find it for a couple of years.
Hmm.
Maybe Dayton.
Maybe.
Yeah.
Yeah, if you go to 250 feet, that's only 0.6 dB a loss, so you might be okay there.
Excellent. Well, thanks for that, Lloyd. It gives me a bit of faith in what I spent my money on.
Yeah, I'm trying to come up with something. I don't think it'll be quite as elaborate as what you have, but at least a single long boom Yagi at this end someday. Working on it. 7.3.
73, Lloyd.
Hey, Dave, I've got a relay mechanism, one of these Dow key things for microwave, and it works great with my preamp that I have in the shack. I've got one of those one of those advanced or AR preamps. And it makes a difference, even in the city with all my noise, because sometimes I get like low noise and I can still hear better with the preamp. And I highly recommend you put that at the bottom of your coax now and be able to switch it in and out, when you transmit. I think you'll see a big difference in what you hear.
Yeah, I will be trying it. Excellent.
I'll come up and help.
Yeah.
I was
Yeah,
just-
I'm wondering if I need a preamp, because at this moment with my zero noise, I can receive all kinds of stations which don't hear me, and I'm not running QRP.
Yeah, you haven't done the moon yet.
Yeah, that's true.
It's a little further.
Yeah, that's true. And most of the guys for example, in South America, they are in the big cities. They probably have a very high noise level.
Yeah.
And usually I can hear them fine when they're running no more than 100 watts, and they don't hear me with a lot of dBs more.
What are you running, Martin, for an amplifier?
I can go up to 2.
Wow, that's pretty good.
So that should be enough, I guess.
Yeah.
if you see birds dying as they fly past your antenna, then you've got
Nah,
enough power.
nah. A single 7 elements doesn't have enough gain for that. But I'm planning to have a 4-bay of 38 elements for 70 inside the 4-bay for 6.
Right.
That has a little bit more gain, then you have more chance of birds falling out of the sky.
Yeah.
So
I
I
don't
hope that won't interfere too much to each other.
I don't know if you guys have ever read the book by John Krause, WHJK, his book called The Big Ear. He was the original guy who developed the helix antennas, and it's well worth reading. He built an antenna for, I don't know what frequency it was 150 megs or something, as big as a football field. I mean, absolutely staggering, some of the stuff he did back in the early 50s and 60s.
Yeah, that's when preamps were 417As or 417Bs.
Yeah.
Little gold tubes. I had those.
Yeah. Yeah, it's a good book. It's well worth reading.
Any other questions, comments? Just as
I see you're using 3 two-way dividers per plane. What is that an advantage above using a single 4-port divider?
That's what, when I decided to put this thing up, I just ordered the 4 antennas with his couplers and everything, because I knew I wouldn't have time to build all the antennas from scratch. So I just put up what came with the antennas, and if I had it to do again, I would definitely look at that.
Because I'm planning to use a 4-port divider.
Yeah, DG7YBN, I think, is the guy. He's got a website describing a lot of port combiner stuff and that, and that's well worth looking at before you get started, Martin. Seems like you know what you're doing anyway, but it's always worth looking at what some of the guys there did over in Germany. Some of it's pretty good stuff.
I don't know if Lance has some comments on that.
Yeah, I built my own four-way power divider, and it is a lot more involved to do that. It's definitely the better way to go than to use all these different two-way power dividers. But if you don't have access to build it, to the parts for building one yourself, and I've got details on mine, on my webpage, you can just use, for a 4-way power divider, you use some good low loss coax like LMR 600 and put a 1/4 wavelength on both sides of a T connector, and then put T connectors on the ends, and you've got your four-way power divider, because a four-way
Right.
power divider, half wavelength long, needs a 50 ohm section. So it's real easy to do with coax.
I got a 4-port divider, so
Gentlemen, a question on preamp. Do you build your own or do you purchase them?
I think you buy it. They're so cheap.
Where-
I think
I bought mine.
Advanced Radio Research, is that what they call
Advanced Radio Research?
yeah, I have a couple of
Yeah, they're-
HA8 ET amps. They probably should
Yeah.
work beautifully.
it? Yeah, they
Downey's Microwave makes them too.
get the gas FET version. Because they've got different ones, and the gas FETs have the lowest noise figure. And they have about what, 24, 23 dB gain, Lance?
Advanced Radio Research.
Yep.
Say Advanced Radio Research Area's got one.
There's one.
Yeah, they're American company.
Yeah. Yeah, you can get them locally here. They're only about a day away or 2 days away by, they'll ship it to you.
Okay,
Pretty
all
fast.
right.
You get whatever kind of connectors. They also sell some that you can put in line. So you don't need an extra relay. You can get them so that they'll switch your power for you as well.
Paul, I've got the same problem you do though with high noise. I'm in the middle of a RF factory around here with 3 huge TV stations within stone's throw and tons. And of course, those things are just porcupines full of all kinds of communication junk.
What kind of antennas are you going to use? Or are you using?
And 5-element LFA. With
I've got the 6-element LFA Max, they call it, which is about 19.6 feet. And I stacked a pair of them and just use a power divider and a couple of equal lengths of coax between them. And it seems to be good enough to, I can really null out the noise. That's the most amazing thing about it. The front to back is incredible.
Well, here in Omaha, I did manage to work several Europeans this last summer
On 6?
on 6, yes.
Excellent, excellent.
Yeah, you can find some good days there. Last summer was pretty good, but this summer is going to be better, much better. The next Zoom presentation we're going to have is going to be with Carl. K9LA is going to do one on the propagation, the F2. I kept telling Carl, I said, I've been operating for many years, and I always got like sporadic E, and I got TEP, but I can never tell when I've got F2. I said, how do you know when you're getting F2 and when can I expect it? I mean, there's stories of guys like back in the 50s who had like 5 watts and a coat hanger, and they're working South Africa from North America. So it was on
Yeah,
me.
back about 3 sunspot cycles ago, maybe 4. I had this really strong signal that was pinning the meter, and the guy had an accent, but I lived in Florida at the time, and I thought, well, maybe it's somebody from England visiting. And it turned out it was a VK on F2. He had special permission to operate on 6 meters because they were still doing TV down there on 50 megs. And he was apparently far enough away he could do it. And I thought he was somebody parked in my driveway. He was so strong. It's just amazing what F2 does, although I haven't experienced much of it, unfortunately.
Yeah, wow.
Remember what time of year that was?
Gosh, in Florida, it's always sunny and warm, so I don't remember.
I know
I'm back
that
in
feeling.
Wisconsin now, though, so I appreciate weather now.
On F2, normally,
the
if it's
Florida
gonna-
guys,
you're going to see it around the.
the Florida guys today were working the South Pacific, so
Oh, you
Yeah,
kidding?
Oh yeah, we had
for
TEP all half the year long in Florida. The conditions are totally
for east
different.
west, you need the solar flux over 200, and it has to happen around the November through February timeframe. It could happen any other time of the year. You're not going to see F2. I've been through a number of F2 cycles, working down to Reunion Island and out to Australia. And of course, New Zealand was a TEP contact around Christmas around 5 years ago. But you get the day, you get the annual north-south. You guys down in Florida normally get it better than we do. We need an e-skip link to get into it from up here up in the north. But with F2, unless the solar flux gets well over 200, you're not going to see any east-west F2 on 6 meters.
So November to February, you say?
Time frame, I've gone back through all my logs, and we've had higher solar flux in mid-year, and you'd think there'd be F2, and no, it didn't happen. So something to do with the geography of it all and of the Earth placement. But yeah, it's all seems to be in that time frame of November through maybe February for F2. Of course, e-skip can happen anytime. Mostly, you know, we're waiting for summer. I see Tak on here. Tak, you still here? Yeah, JA7QVI, one of our big 6 meter guys, just recently worked at Tak on 12 to make it, I think, a 10 band from 160 up through 6 meters. So good to see Tak on. He's always has a big signal on 6. But other than the e-skip, which we get every year, it's going to take a lot of F2, a lot of MUF, very high MUF, a very high solar flux number to make it happen for east-west F2, unfortunately.
Yeah, last
Rich,
year.
Rich, you slay me when you talk about being up north. You have no idea what it's like to be in Western Montana.
I remember when we first worked back when you were up in New England, up in were you in New Hampshire or Vermont? You were way up there, WA1JXN, right?
Yeah, in Vermont.
In Vermont, and that's up far north. And there's benefits of being up north and being up, of course, in New England. And of course, the guys in New England complain how well the guys in VE1 work, and the guys in VE1 complain how good the guys up in VO1 and VO2 have. So closer you are, the better. I'm only about 50 miles from W3 LPL, and there are days when he and the guys up in Maryland, 50 miles away from my Virginia QTH, are working stuff I can't hear. Then there are times I work stuff and they don't hear. So that's the magic of Magic Band.
Or the tragic band, as some call it.
I just looked up my VK4 F2 contact on 6 meters from years ago. It was on November 6th with VK4 Alpha Bravo Whiskey.
My VK contact was I believe in January, and that was a long haul, and that was when 855? Forgot, it's been so far. We had a coordinating frequency on 10 meters. And he says, I'm on 6 meters, and I got on CW, and he was on phone, and we worked cross mode. But that's when we didn't have the internet back then. We had to use 10 meters for liaison.
Yeah.
That's
Yeah.
good.
Over here, TEP is getting bored. It's getting boring. It just stopped, I think, about 2 or 3 weeks ago. So we had it was very easy to work on VHF on 2 meters with Buenos Aires. It's 5,500 kilometers with 596 signals daily, nearly for 3 months long.
Back in the 60s, I was in the army in Pakistan. We're monitoring the Russian missile launches, and they used VHF, and we picked up an awful lot of stuff with their low-powered VHF. But when the skip was in, and so that was fun. It was secret at one time, but I can tell you right now, since it's all over the internet. But,
Yeah, well, last couple of weeks I've been lucky to I got into Charlie Echo 2 and Charlie Echo 3, and I was really happy because the big station, the big gun up here in Colorado is the K0GU J, and CE2C SV told Jay that I was stronger than him. And I'm in downtown Denver, so I felt so much better.
Yeah, usually Dale CE2SV is 5.9 plus here on the meter. He's always very strong.
Yeah, he's got a good signal. Must be right. Oh, he's out in the water. Isn't he in Valparaiso? I think.
Yeah.
Which is right next to the ocean.
I got a question. My VH activity is basically just 6.2 and 432 sideband. But during the July or the CQ VHF contest, I got a 4-element 6-meter yagi at about 33 feet. And I had my first JA contact on FT8. And I was really excited about that. I was just curious of what type of propagation that would have been from Milwaukee, Wisconsin over to the JA land at that time of the year.
Was that
SSSP,
Huh?
short skip solar solstice propagation.
It was FT8.
Yeah, SSSP. You Google the letters SSSP. There's a good article by JE1 BMJ. And he tells all about it. And I think it was published a number of years ago and it's still available on the internet.
what's the call sign again?
One Bravo Mike Japan, big 6-meter up.
I got 1 BMJ. What was the first letter?
Japan Echo 1, JE1.
Okay. I got a dozen Japan July 2nd last year. Was that about the same time that you were doing it, Gil? Was it early
Whenever-
July?
Yeah, whenever the CQ VHF contest was.
Yeah,
Right, right towards the end.
yeah, I got like a 20-minute window. I had about a dozen of them come in. And again, same as you, 4-element, 30 feet off the ground.
Yeah.
Up at the lower antennas in the high one. I've got a 7-element LFA at 77 feet. And at the recommendation of Frank W3LPL, I said, put one up at the lower heights. So I put a temporary 7-element K1JX antenna on the second tower at 40 feet, and they ran circles around the high antenna. Same size.
That theory holds then, does it, Rich?
Oh, it sure does.
Wow.
Yeah.
He had 50 feet he talked about.
Yeah, he's 50. I'm going
He's
to raise my other
50.
one up 50. I'm adding a second one with a bip-op switch. But
Interesting.
into Caribbean, it's even more dramatic. The skip, the lower one just far exceeds the higher 7-element. It's dramatic.
So if I put a 5-element or something like that at 51 feet on my tower, how would that perform against the third one at 33 feet?
That would be
A
much
little bit
better.
better, a little better. Yeah, I think 50 is about optimum, Frank.
That's the optimum. We had a presentation a few weeks ago about
Yeah,
that.
the incoming angle is about normally 15 degrees or so. And
Yeah.
on the 7-element up at 77 feet, there's a null at that point.
Yeah.
So you don't
Yeah,
want to
that's
null
what
at the optimum
Frank
angle.
was talking about. At 0 to 15 degrees.
Null there.
Mhm.
That's interesting.
So maybe it was TEP from here to Japan.
SSSP. Summer
SS.
solstice short skip propagation.
Oh,
It's a E skip on either end of the link and a chordal hop across the pole.
what was those letters again? SS what?
Sugar, Papa, SSSP.
Oh, thought you
Summer
said
short
D.
skip summer solstice
Okay, all right,
propagation.
that makes sense.
Okay.
Yeah. Cool.
Now you have all these letters to figure out. TEP, E,
Well, that's easy.
SSSP, sounds like alphabet soup. But interesting to learn it all. Okay, guys, listen, it's been going for quite a while here, and really appreciate all you guys attending, and definitely appreciate Dave going to all the work putting this thing together. And I just formatted the presentation a little bit for him so I could squeeze it out here. One of these days, Dave, you're going to get real internet at your house, so you can get on there without the 2.5 second delay.
Yeah, one of these days. When I get back from where I'm going over the next couple of weeks, Paul, we'll talk about if you're interested in putting your antennas when they get moved up here, up this building in Greeley.
That's an idea. Maybe I'll come up and just take a look with you. Maybe when you get back, give me a holler and I'll drive up.
We've got a flat roof, and we could do more or less what you've got at your daughter's place. Anyway, hey, it's nice talking to you guys, and I've learned quite a bit there listening this evening.
Thank you, Dave. MacGyver would be proud of some of the innovations you did there.
Great
It's a hand to no one.
Yeah, and
Good
I'm
luck,
looking forward
Dave.
to.
Let me know when you need a flame test.
Yeah, I will, Lance. Thanks very much. And I'll send you my email address.
I'm looking forward to work you guys either on E or via the moon
Absolutely.
or on any other propagation mode.
Yeah. I'll look for you this summer, Martin.
Oh yeah,
Yeah, me too.
I will be on nearly every day.
Gotcha,
Excellent.
guys. All right, guys, have a good night, and thanks again for joining.
Yep, thanks, everyone.
Bye for now.
Good night. Good night, Bill.
All right.
See you,